Hi all, I hope everything is going well with yourselves and your families. So we're just going to continue working on gases and the atmosphere. But before we do that, I just thought I would take an opportunity to quickly review all of the Charles law and Boyle's law stuff. Particularly paying attention to the math, because I know that might be a struggle for some of y'all. So to get started, I thought we would first review Boyle's law. Okay. So remember, Boyle's law states that the pressure of a gas is inversely proportional to the volume. So that's what it means. So pressure is inversely proportional to volume. And what does inversely proportional mean? When we say that pressure is inversely proportional to volume, what does that really mean? Well, what that means is that if pressure goes up, volume will go down, or if pressure goes down, volume will go up. So in other words, they always do the opposite thing. Graphically, if we were to plot an inverse relationship like this, of let's say volume versus pressure, it would have a downward exponential type look to it. Because again, if we look, going from left to right, pressure is increasing, but volume is decreasing. So they have that inverse relationship. So we know what Boyle's law is, we know what it means, but we need to consider what it is mathematically. And the equation is P1 V1 equals P2 V2. So that means if you take the initial pressure and multiply it by the initial volume, it will equal the final pressure multiplied by the final volume. Okay. So because the equation looks like this, you're always only going to have one unknown. So you're always just going to end up dividing to find what you need to know. So let's just say your initial pressure was 4 atmospheres and your initial volume was 3 liters. Okay. And you wanted to find out what the pressure would be, so you wanted to find P2 when the volume was 4 liters. Okay. So we would need to get P2 by itself. And in all of these Boyle's law questions, we're always going to end up dividing to get our unknown by itself. So we're just going to end up dividing both sides by 4L, so it cancels, leaving P2 by itself. And dividing that side by 4 liters as well. The units of liters cancel. 4 divided by 4 is 1. So P2 is 1 atmosphere. So with Boyle's law, regardless of if you're trying to find a pressure or volume, you're only ever going to have one unknown. And because it's P1 V1 equals P2 V2, you're always just going to end up simply dividing. So that one sort of is quite straightforward. Charles' law can be a little bit more complicated in terms of the math. So let's look at that one really quick. So that was Boyle's law. Let's look at Charles' law. Okay. So Charles' law, remember, states that the temperature of a gas is directly proportional to volume. So temperature directly proportional to volume. Okay, so this time we're saying directly proportional instead of in Boyle's law where we were saying inversely proportional. So now that we know that, what does that mean? Okay, and by the way, you might see it written as volume directly proportional to temperature. Doesn't matter which way around you have it, it's the same thing. So what does this mean? This means if temperature goes up, volume goes up, or if the temperature goes down, volume goes down. So in other words, they follow each other. If one goes up, so will the other one. If one goes down, so will the other one. They always follow each other. Okay? So if we were to look at a graph, if we were to do a graph of volume versus temperature, it'd be a straight line going up. Okay? Because as we go from left to right, temperature is increasing. And if we look, volume is increasing as well. So you need to be able to look at the graphs of Charles' law and Boyle's law and be able to tell us which graph you're looking at. Okay, and in terms of math, the equation is V1 over T1 equals V2 over T2. So if you take the initial volume and divide by the initial temperature, it will equal the final volume divided by the final temperature. And I always like to remember this one as Charles likes to watch TV upside down. And we say TV upside down because V is on top and T is on the bottom. So the word TV is upside down. Okay. So in all of these types of questions, we're always going to have one variable. So one unknown. So let's do an example really quick. So let's just say our initial volume was 4 liters. And our initial temperature was, let's say 100 Kelvin. Okay. And our final volume, let's say was 3 liters. And we wanted to find what the T2 was. Okay, so with all of these questions, right, Boyle's law and Charles' law, we're always going to have 4 variables. And we're always going to be trying to find one thing. So with Charles' law, that unknown can either be on the top or on the bottom. So in this case, what we're trying to find, T2, is actually in the denominator. So what I'd like to do when the unknown is in the denominator is first calculate what this number is. So let's divide 4 by 100. That's going to give us 0.4. And we'll keep our units as well. So 0 divided by 100, that number is 0.04. My bad. So it's 0.04 liters over Kelvin, because none of the units have cancelled yet, equals 3 liter over T2. So to get T2 by itself, you can just think about T2 and this entire thing on the left hand side switching places. So that would be T2 equals 3L divided by 0.04 liters over Kelvin. And just like that, the liters cancel. And since Kelvin is on the denominator here, it's going to flip up to the top. So we enter this number now into our calculator. It would be 3 divided by 0.04. Okay. That would be T2 equals 75 Kelvin. Okay. Does that answer make sense? Well, we know our initial volume was 4, and our final volume was 3. Okay. So we know the volume decreased. And since they're directly proportional, we would have expected the temperature to decrease as well, and it has. So it makes sense. Okay? So just to be clear again, if what you're trying to find is in the denominator, you can just work out what this number is, ensuring all of your units throughout the question are the same. So liters and liters, Kelvin and Kelvin. Once you get that number, you can switch T2 and this whole thing to get T2 by itself, and then you get a number. Okay, and let's compare that to what it would look like if the unknown was in the top. So let's just say our initial volume was 5 liters, our initial temperature was 50 Kelvin, and what we wanted to find this time was V2, and we knew the initial, or final temperature I should say, is 75 Kelvin. How would we find V2? Well, this time V2 is on the top, so all we would need to do to get V2 by itself is multiply both sides by 75K. Then those cancel, the Kelvin cancel, so it's just 75 times 5 divided by 50. So we get V2 equals 7.5 liters. So temperature increased, volume increased as well. It makes sense. Okay, and we can just go over that one more time just to be clear. So if you have, let's just make up some random numbers, so like x over y equals z over a, right? And if you want to get a by itself, we can just switch the whole of a with what's on the left hand side. So we'd say a equals c divided by x over y. Okay, and if we wanted to find, if we rewrite all that, if you wanted to get z by itself, c would just be x over y multiplied by a. That's just a quick recap of the type of math that you need to do these types of questions, the algebra. That's pretty much it for this video. The next video that's coming up is going to be Gay-Lussac's law. Have a good one.